So I'm going to be doing number 28 from section 3.5, and this question describes two stones that are thrown vertically upward with initial velocities of 48 feet per second at the same time. So the first stone is described by the function g. It is negative 16t squared plus 48t. 48, of course, being the initial velocity. And the second stone is actually thrown from a bridge, which has almost the same equation, except that it's thrown from an initial height of 32 feet, as it is thrown off the bridge. So the first question is, show that the stones reach their high points at the same time. This is pretty easy to do. So if we graph it like this, oh sorry, my lines are not straight at all, it's fine. GT is going to look something like this. So from the negative 16, we know it's going to be an upside down parabola. And FT is going to look kind of like that. And the important thing to notice is that these are almost the exact same function. The only difference is this vertical shift on FT. So, because the shift is only vertical and nothing's different between them horizontally, we know that their high points are going to be in exactly the same place. So for part B of the question, it says how much higher does the stone thrown from the bridge go than the stone thrown from the ground. So, I mean, as we can see, the equations are essentially the same. Ft is just gt plus 32. So since we know that g of t actually describes a position from the ground, if we say that th is the time at which the stone reaches its highest point from the ground, and h is the distance between the stone and the ground, then GTH equals H. Then F of TH equals H plus 32. So basically, that's a very long-winded way of saying that this distance is equal to 32. And what that means is that the stone thrown from the bridge goes 32 feet higher than the stone thrown from the ground. Alrighty, and part C asks us, when do the stones strike the ground and with what velocities? So for this, I'm going to start with g of t. When the stone strikes the ground, we know that's going to be at position 0, right? So I'm just going to set g to 0 against the equation and use that to figure out the value of t. So now that I know that t equals 3, I can just plug it into the derivative of g. So the derivative of g is equal to negative 32t plus 48. So if I plug 3 into that, it will give me the velocity of the stone when it is at point 0. So the answer ends up being negative 48. And this makes sense in context because we know that the initial velocity should be the same as the terminal velocity before it hits the ground, neglecting air resistance. So for the second one's going to be a little bit funkier because it's the one that gets thrown off a bridge. So I'm still going to set 0 against the equation to figure out t. I am going to have to use the quadratic formula to figure this one out. So we can scratch that out because you can't have negative time. This one, the negatives actually cancel out. So this will be our actual time. And I'm going to get that the final velocity of the stone thrown from the bridge is 66 feet per second in the downward direction.